presentation I want to share with everybody today is a little bit of a broader view. And really the reason I wanted to dig into this a little bit is just to try to help everyone kind of think through some sort of social sustainability issues around dairy. So within the industry, we maybe don't talk about this on a daily basis, but we're certainly getting challenged on a regular basis as to what's our role in society, what's our role in the food system, and certainly some people are pushing back against the livestock industry in general, saying that we're sort of a net negative impact on society. So I want to try to dig into those questions a little bit and put it a little bit of frame of reference around some of the dietary things that Dr. Locke presented and others have worked on as well. So I think one of the things driving these sort of criticisms or the sort of contentious arguments around what our food system should look like is just this overarching question of whether the planet can sustain 10 billion people. And that's the projections, the current projections for populations around the year 2050. And as probably everyone listening is aware, there's not any new land being created. And the amount of arable land available for agriculture is not likely to change. Really, the only way we can feasibly change that is through some relatively drastic measures to make more pasture land available for row cropping, or to cut down forests, which in the context of the climate change issues and the carbon cycle is probably not a good idea, in addition to other challenges with that. Okay, so when we look at total land available for growing crops worldwide, it's a pretty small chunk of the globe. And then on top of that, one of the things we see is a fair bit, more than half of that land goes to things other than producing human food. Okay, so on the surface already, people get alarmed about that. And in fact, if you look through the literature in the space where people are kind of studying the whole global food system and thinking about ways to improve it, this is something that comes up a lot, is that maybe we have too much land devoted to growing feed for livestock, and that we could have a much more efficient, sustainable system if we use most of that land for directly growing human foods. So this rotating globe here shows a range from green to red, where green is where crops that are grown are going to human food consumption directly, and the red would indicate where most crops are going to feed livestock. And it's basically completely overlapping with relative wealth. Okay, so parts of the world that are relatively wealthy, where agriculture is intensified, we tend to feed a fair bit of the crops to livestock and enjoy animal source foods. And so people that are really focused on concern about sustainability, particularly around the food system, they are told from many sources today that ruminant-derived foods especially are the least efficient way to produce food. And not all of these are necessarily coming from sources that are just out specifically to destroy animal agriculture. I think it's too easy to wave your hands at that and say that that's the case. So for example, this infographic here is not explicitly wrong. It's from National Geographic, which I consider to be a fairly reputable source of information. But as we'll talk about in a minute, despite presenting factual information showing how many pounds of feed are required to generate 1 pound of increase in body mass, may not be the most relevant metric to use to look at efficient food production. So we'll talk about that. But anyway, this is the kind of thing that consumers would often see today when they're just turning to the popular media. Okay, so with that, I'd like to air some grievances with some of these analyses. Okay. First of all, in many of the things, and I think if you can learn to spot these issues, this can be explained to people pretty easily. I see infographics and information that would compare foods on even a mass basis, so a pound for pound basis. Obviously, a pound of meat is far more nutrient dense than a pound of many other types of food, so that's not fair. But even comparing on a calorie per calorie basis is really quite misleading for any high protein food. So even if you include things like legumes, there's really no high protein food that will ever look efficient compared to our staple cereal crops: rice, corn, wheat. On a calorie per acre basis, we're not going to touch that with any high protein source. But of course, we don't just need calories to live on. And so we should be looking at high protein foods on a protein efficiency basis. So there are some analyses that do that, and some of those are still highly critical of animal source foods, which is fine. They're at least trying to be more fair. But even then, we have a bit of an issue where, again, if you just say compare growing legumes to devoting land to growing feeds for livestock and consuming animal source foods, that does not account for differences in amino acid profile. And the amino acid profile of animal source foods is the most appropriate for human amino acid needs. That doesn't mean that you can't come up with a vegan or vegetarian diet that has an appropriate amino acid mixture. You can, but it's more complicated. It's not as easy to do. And if you have a limited amount of access to protein, that can be a challenge. And beyond the protein issue, of course, animal source foods are very key sources of other nutrients as well, including certain vitamins and minerals. So the bottom line, this isn't to throw sort of these global analyses completely under the bus. The bottom line is it's just actually quite difficult to come up with an apples to apples comparison, if you will, of different sources of key nutrients, because every type of food has different sort of strengths and weaknesses in terms of meeting human nutritional needs. The second issue, and this one is, people should not fall into this trap because it's so obvious. Not all animal feeds have an equal resource or environmental cost. And this stupid little picture here makes a very obvious point to most people listening. But a pound of crop stubble or hay should not be counted with the same weight as sort of human edible corn. And the infographic from National Geographic that I shared a minute ago is a really bad example of that. So they're counting 6.8 pounds of feed going into beef cattle as essentially equivalent to the feed going into aquaculture, which, if you know anything about aquaculture, and I'm not an expert, but they still to this day have to rely on wild caught fish as a component of the feedstuffs for farm raised fish. So aquaculture, the point is not to throw aquaculture under the bus either, but the point is the resources, the feed resources going into raising fish are inherently far more valuable or have a far greater resource cost than some crop stubble that is a component of feeding cattle. Okay, so comparing those sort of on an equal weight basis of feed is just disingenuous and misleading. Beyond that issue, it's important to recognize when we do some of these global analyses that saying that a lot of land goes to grazing animals, for example, and sort of saying, well, why aren't we raising food for humans instead of being inefficient with that, completely ignores that much of the land around the world is absolutely just not suitable for efficient crop production. In many places, it's simply too arid. There's not enough rainfall to make it a viable place to grow human food crops. In other places, it's too steep that you couldn't raise crops like that without massive erosion problems. And again, everybody in agriculture kind of knows these things, but those nuances are sometimes lost in these global discussions. In addition, and this is an area that more work is needed in, but in terms of sort of justifying ruminant agriculture and production of crops as an efficient way, a component of the food system, we need to better understand what are the positive impacts of perennial forages on soil health and even carbon sequestration. Okay, so some of the really drastic commentaries that are out there suggesting that we should just completely eliminate ruminant agriculture and that would make the globe more sustainable, I can dismiss fairly readily because they employ very little nuance, very little understanding of the complexities of agriculture on the ground. But there are some more reasoned proposals out there that suggest maybe things should look a little different in a perfect system. And this is one that I think is worth engaging with. So this is a concept at least spelled out most clearly in a paper published 11 years ago, where they use the term ecological leftovers to describe sort of one view of how animal agriculture might fit most efficiently into the global food system. So in this concept, the first premise is that arable land that's available should mostly be designated to grow plants for humans to consume. Okay, and we can debate how perfectly that fits, and people would have different ideas on that. I'm not necessarily embracing that, but that's the first premise. The second is that animals should be fed biomass that's unwanted by or unsuitable for humans. And thirdly, that we could justify semi-natural grassland for livestock grazing if it's justified by reasons beyond just meat and milk production. In other words, if we need grazers on that land to sustain biodiversity or conserve soil as opposed to growing crops on it, then it makes sense to at least capture the meat and milk benefits of having ruminants on that ground, or grazers at least. Okay, so again, I'm not presenting this necessarily to endorse this fully, but I think it's an interesting concept. And I particularly want to engage with this concept that we've sort of already dived into with Dr. Locke's presentation. But I think most people in ag wouldn't be opposed to this concept that to the extent that we can, without causing other problems, why shouldn't we use sort of potential waste biomass from other crops, from other processes to help raise livestock? And we've done some reviews kind of on what kind of global advice can you give on using byproducts or co-products, some people like to call them, in feeding dairy cattle. And this is just a brief list of the really wide variety of things that people feed to dairy cattle in different places. And it's, of course, it's very regional. It's based largely on what major industries are present in different regions of the world, because most of these things are cost effective because they are sort of supplied in excess in one location. And so we have huge regional differences. But if you look even just within the United States, if you look around the country, and these are all pictures of feedstuffs that people feed. And of course, California is especially known for the variety and the amount of byproducts they have available. But, you know, Michigan, this isn't uncommon either, to have a fairly wide variety of things available to different farms. Okay, so that was kind of the lead in. I want to now share with you some of the work that my team did. So I just moved to Michigan State at the beginning of 2020. And so this is some work that was mostly completed during my time at Kansas State University. And I especially want to recognize Kayu Takaya and Caroline Ilioya, who were kind of the leaders in graduate school of this project that we just got published in December 2019. So our objective in this study was to kind of ask, how far can we push this concept? So we took cows at the Kansas State University dairy and either fed them a conventional lactation diet and conventional for that part of the world for what we do at that dairy, I'll show you in a second, against a diet that was formulated to include almost exclusively byproducts of human food, fuel, and fiber production. And I say 95% because we ended up adding some things to try to make this palatable and workable. We took that even a step further, though. We said we weren't willing to use feedstuffs that were grown on arable land that could be used for human food production. So you could do this in a somewhat disingenuous way by, say, feeding a very high forage diet, but you've taken land that, you know, was growing corn, for example, that could have been harvested as corn grain and used for human food, and instead diverting it for cows. So we said, we don't want to do that. We want to take this all the way into this eco concept and see what we can do in terms of maintaining productivity in that situation. So our hypothesis was that if we were careful in formulating an extreme byproduct diet like this, that we could support milk yields of at least 80 pounds per day. And really the key focus of this study was, could we, by doing this, improve the return on human edible nutrient investment? So what do I mean by that? So this is really getting back to the idea that not all animal feedstuffs are created equal. Not all should be considered as having the same resource cost to society or environmental cost. And if we can minimize the human edible inputs into the system, we're kind of negating the food versus feed competition debate, turning to this eco concept, and essentially making the dairy system sort of a free lunch, if you will, taking things that are essentially a waste stream and making something useful out of it. So how did we do that? Well, this was tricky. This is not something I would go on a commercial farm that needs to make a living tomorrow and say, start feeding this diet. But let me show you what we came up with. So we used a optimizer and said, here are the nutrient constraints that we need to meet. And you can see in the control diet here, already we're feeding over 30% byproducts. So a fair bit of corn gluten feed, about 5%, 4.5% cottonseed. And so already, and you'll see that in the calculations, a fair bit of feed here coming from non-edible sources, non-human edible sources. In the byproduct diet, we continued to rely very heavily on corn gluten feed, but brought in some hominy feed, wheat middlings, porcine blood meal, a post-extraction algae residue, which was actually a product of a Department of Energy effort working on algae as a biofuel source. So this is after the fat was extracted from that. And then the hardest question for us really was, okay, if you're not going to use dedicated forages that were grown on land, put into forage production, what options do you have to meet fiber requirements? Well, we came up with two. One would be to use crop residues. And in this case, we ended up using wheat straw. So 20% of the diet was wheat straw. The other option that at least we justified in our minds was that in a double cropping system, which works at least in Kansas, if you're growing a winter crop opposite of growing corn, that could in theory be used for human food production, that winter crop should not be counted as taking land away from human food production, because you can't, in that part of the world at least, you can't produce two crops that are both going to feed humans. So either winter crop or forage, crop stubble would be kind of the two options in that sort of concept. Okay. So here's what the mixed diets actually look like. And if you've fed dairy cattle before, I don't think anybody would say that the diet on the right looks like a lactating cow diet that they've ever seen. When we put it together, we probably were a little nervous about whether we'd taken on more than we could chew here. But that's what it looked like. So the diet on the left is the conventional, the diet on the right is our eco diet, we'll call it for short. And again, nutrient spec-wise, it didn't line up quite as perfectly as we'd hoped, but when we analyzed these diets at the end, you can see we ended up with fairly typical nutrient profiles across both diets. Okay. Well, so I do have to acknowledge here that one issue we had in feeding the byproduct diet is we did have one cow that went on hunger strike. She absolutely would not eat this feed. And after a couple of days of her eating essentially nothing, we ended up giving up and taking her off the study. So that's important to acknowledge. Again, this is a very extreme example. And there's some cows that just couldn't manage that. However, in general, we were pleasantly surprised by how this performed. So to set you up on these graphs here, this is on the left, just raw milk yield, and then fat corrected milk yield on the right. In pounds per day on the y-axis, and the control groups are on the left side of each graph and byproduct on the right, and we split this up into cows that were multiparous and primiparous. So we can see here is that going from the control diet to the byproduct diet, we gave up about 8 pounds of milk and actually over 12 pounds of fat-corrected milk in the multiparous cows, okay? But again, given the constraints we put on ourselves, not terribly surprising. What was interesting is in the primiparous cows that had lower nutrient demands, no change in milk yield and a very marginal change in fat-corrected milk yield. It's not statistically significant. So one way that I think through this is by putting those shackles on ourselves in terms of how we put that diet together, we were able to formulate a diet that could meet the needs of a cow, you know, making the lower 80s in terms of milk yield, but it couldn't really keep up with a cow that wants to make 95 pounds of milk or more. Okay. So not too far off, actually probably better than I thought it might work once we actually saw the diets. So here's the trickier part. So when we actually go into analyze this and ask questions about the return on human edible nutrient investment in this system, you have to start asking, well, what's suitable for human consumption? It seems like an easy question, but when you actually dig through different papers and how they've handled it, it's all over the board. Okay, so again, we wanted to be as tough on ourselves as we could be, if you will, or as tough on the dairy system, and say, let's really look carefully at this system and see what could actually go into the human food supply. Okay, but we wanted to make it feasible as well. So we ended up looking at 3 different scenarios. So the first scenario we looked at would be equivalent to our current US food system, where we have nearly unlimited choices. Okay, the coronavirus scenario aside, we're used to having nearly unlimited choices for foods. And in this scenario, there's things that people simply don't eat. Okay, but we absolutely, of course, need to acknowledge that the corn grain going into these cows could have gone to human consumption. Soybean meal that could have been used to produce tofu or other products, we should consider that as human edible. And then this is something some people don't do. So the corn silage component of this, again, trying to be as fair as possible, we said we really should consider the corn grain component of that as human edible, because it is. And just because you chopped it up with all the forage doesn't mean that it shouldn't be considered in that. In the byproduct or the eco diet, really the only thing that we considered human edible in this scenario was molasses. Okay, so then we went through and you said, well, among the things that are human edible, how much protein was actually provided to each individual cow per day in that scenario? And in the control diet or the conventional diet, about a kilo and a half of edible feed protein, human edible feed protein, was provided per day. And the return on that was about 1.2 kilos of milk protein. Okay, so we'll come back to that in a moment, but I'm just wanting to walk you through how we did these analyses. In the eco diet, very, very little feed protein available. We didn't consider non-protein nitrogen as human edible feed for obvious reasons. So almost no inputs, and again, just slightly lower milk protein output there. So then we thought about another scenario. So what about a scenario where we don't have such unlimited food supplies and people have to turn to things that they maybe currently would turn their nose up against? So certainly hominy feed, it's a little different than the hominy product that you can find in a grocery store, but not so different that humans couldn't eat it. So we thought it was fair in a thrift scenario to consider hominy feed to be human edible. And then wheat middlings, it'd be sort of like oat bran or wheat bran. It's certainly possible that you could mix that into some food ingredients and get something edible out of it. Okay. So on the conventional side, again, no real changes here. We didn't bring anything else new in terms of being consumed by humans. But in the eco diet, now we've jumped to about 1.1 kilos of edible feed, human edible feed protein per day. Okay, and obviously output isn't any different. So these are just different ways of looking at the same data. So we then thought about the most extreme scenario. Okay, so here we're starting with a thrift scenario. And now we've said that land is highly limiting as well. And again, to be completely fair, then I think we have to consider that land devoted to producing alfalfa, we should at least acknowledge that that land could have gone instead to growing a mixture of a cereal grain and an oil seed to produce protein and energy in a mix that would match that of milk. So in other words, that whole concept of diverting land from making feed for animals to making food for direct human consumption. And so we put in a factor saying, accounting for the land that was used for alfalfa and considering if we had diverted that to direct crop production for humans. So in that scenario, our resource cost, if you will, is equivalent to 2.1 kilos of human edible feed protein per day for those cows, and no change here on the eco side. Okay, so that's how we thought through this. So one of the points I want to make is whether or not different components of the food system look efficient depends a whole lot on the assumptions you make. And compared to some of the work that's out there in terms of global food system analysis, this analysis that we did, which took a fair bit of time, is tiny. People are trying to do things like this, encompassing the entire globe, encompassing all food products going through the system. They have to make an infinite number of assumptions. And this isn't to criticize those analyses, but again, it's very, very hard for them, even with the best of intentions, to incorporate all the nuances that are here, even if we look at a single product in just a couple of small different scenarios that are all potentially feasible. Okay. So if we boil this down a little bit and sort of ask a simpler question, in our current US scenario, which I would say is essentially the choice scenario, what's the return on human edible investment in the dairy cow? So in other words, are we actually wasting resources by feeding dairy cows and getting the milk for human consumption? So on the conventional diet we fed in these studies, on an energy basis, we recovered about 95% of what we put in. Okay, so there's about a 5% loss there. And on the protein side, we recovered about 82% of what we put in. So again, about an 18% loss there. Here again, as I pointed out before, there's some nuance lost already. So milk protein coming out from an amino acid basis and from a digestibility basis most likely is not going to be the same as the feeds going in. In fact, it's going to be upscaled protein quality. So I wouldn't necessarily say that we're wasting 18%. The recovery is not massively greater than 1, but I think on an actual nutritional basis, it's probably pretty close to 1. However, just to say how extreme can we go in terms of cranking this up with our very crazy eco diet that we fed, we could get that energy return on human edible inputs to be 7.7. Okay, so for every calorie of human edible feedstuffs that we put into those cows, we got over 7.5 calories back. And on the protein side, it's even more extreme. So for every gram of human edible protein we put in those cows on the eco diet, we actually got 20 grams of human edible protein back out. Okay, so if this really is the key metric that we want to use to drive a better food system, if you will, we have a lot of room that we can shift this in feeding dairy cattle. Okay, but I think it's also important to recognize and ask what forms of malnutrition are actually the most likely on a global level. So some people in the fear-mongering world don't recognize or know this, but today we actually have plenty of calories, plenty of protein, and actually plenty of every nutrient, as far as I can tell, to meet the needs of everybody in the world, and probably to meet the needs of 10 billion people. The problems are, A, in doing so, are we having unacceptable environmental costs? B, are our food systems, distribution systems such that those nutrients are wasted in some places and not delivered in sufficient quantities in other places. Okay, and so this is a nice paper published a couple of years ago now in the same journal that we published in, that tried to assess globally what's the supply of all the different essential nutrients for humans and which ones are the most at risk of being deficient. And this is not the only nutrient that was considered to be sort of borderline, but one of the ones they highlighted was lysine. And this is a direct quote from the paper: whilst the average diet is not lysine deficient, if meat and dairy products were removed, the global food system would be severely lysine limited. Okay, so let's think about lysine then. So if we went through the same analyses for essential amino acids, and even in the conventional diet where we're not really targeting a massive return on human edible inputs, we got about 1.5 grams of lysine back for every gram of human edible lysine into the system. In the eco diet, under this choice scenario, that becomes a massive number. So for every gram of lysine we put into the cow, we got 471 grams back out. And I think, some of these numbers really just point to, I think, the two incredibly cool things about ruminants. Their ability to degrade fiber and turn that into energy that can be then used to produce much more nutritious products like milk. And B, their ability to upcycle nitrogen. So they can take nitrogen sources that would be toxic to humans and actually turn them into true protein that can nourish people. Okay, so a few caveats and cautions here. I don't want to overstate, the work that we did. First of all, this is only assessing a very narrow question. So if we're only asking what can we do in terms of loss or gain of human edible nutrients in feeding lactating dairy cows, and I definitely want to acknowledge that the eco diets that we tested, I showed one of them, are not feasible for industry-wide use currently. The very first simple reason for that is if everybody were to jump on these kind of diets, all these byproducts would be used up very quickly. So we don't have adequate supply to even do this if we wanted to right now. But it's kind of a proof of concept. How far could we take this in theory? And the other thing we have to acknowledge is in the real food system, we don't have the luxury of just looking at carbon footprint or just looking at human edible feed return on investment. We have to also consider economics, the resilience of the system, labor efficiency, energy efficiency, water efficiency, and all those things have to be combined. And often when we see, really highly critical pieces of data, they're looking at a very narrow prism from which to look at a system that's very complex and has to fit into a world with lots of things going on simultaneously. Okay, with that being said, I think one of the really interesting things from this, again, we tried to be as tough on the dairy system as we could without being unfair. And I've become at least convinced that at least for some nutrients like lysine, it's pretty clear to me that our modern dairy production systems do give us a net return on human edible inputs. Okay, so I have no trouble sleeping at night. So this is a graphic from the EPA kind of detailing what are considered to be the best ways to do with excess food supplies. And it tends to be built on wasted human edible foods, but it also kind of applies, at least in part, to what about those components of crops that are not used. So again, think about cottonseed is the one I love to talk about. So your t-shirt's made of cotton. There's a very nutrient dense seed that's not used to make your t-shirt. Humans can't eat it. There's a toxin there, but it's a terrific feed for cattle. And if you took cattle out of the equation, what options do we have? And you can go down this upside down pyramid here and see that, yeah, there's things we could do, but from an environmental standpoint, they're far less preferable to using it to feed animals and produce human food out of that. Okay. So I think to me, and we can argue again about details, but in general, livestock and especially ruminants play a really critical role in making nutritious food out of these products that would otherwise just be lost from the system. It doesn't mean we need to push it to the extreme, but in this experiment, we were just asking what would happen if we tried that. Okay, so this is my contact information. Love to engage with you on these topics if you're interested. And